All right, so if I'm going to do this one, if I am going to do this problem, and if you want to continue working on your own, that's perfectly fine. Just keep your voices down so that other people can hear. Again, remember that when there is a problem with two separate things, look for the bridge. Look for the thing that connects the two. I would say the two things that connect here is the distance. Both of these things fall the same distance. And then if we look at, if you think of just the position functions of where these things are, then I think it leads you down one road. But I'm going to take a cue from the last problem. I don't know if this will work, but I'm thinking it might. If I use v f squared is equal to v0 squared plus 2ax, then I know the acceleration of the watermelon. I know its initial velocity. I want its final velocity. And I don't know how far it fell, but I know that it fell the same distance as Superman. So if I solve this for x, I get x equals vf squared minus v0 squared over 2a. And when I look at Superman, he's moving at a constant velocity. So his x is going to be, oh, I don't have his time either.
We have to find him first.
Yeah, we have to find time, sadly. Sad face. Oh, I thought I'd be able to do this a quick kind of sneaky way, but it doesn't work. All right, so we're going to have to do it the hard way. So then, of course, the position function of the watermelon is just v0t plus 1/2 at squared. And then the position, that's w, and then the position function of Superman is just vs times t. So what does that do for us? We know that these two are the same, and we know, yeah, two equations, two unknowns. Oh, well, actually, that goes away, so we know that. Intriguing. So can we find something out from this? If we say 1/2 at squared equals vst, that goes away. Then we get t is equal to 2 vs over a. So 2 times the velocity of Superman. So that's, what, 70 divided by 10. So that's around 7 seconds. And now once we know that, we can go ahead and just use the first equation on our formula sheet, which is v is v0 plus at, or 70 meters per second. Again, remember that each of these equations is derived from the taking the acceleration, doing the interval backwards, integrating from that. So we start with the acceleration of gravity. We start with the thing that we know, and we integrate backwards to get all the equations to solve this.
What do you get for B0? 0?
Yeah, because this v0 was for the watermelon. Its initial velocity was 0.
Oh, okay.
Because somebody dropped it.
Then why is it 70 meters per second? Wouldn't it be negative 70 meters per second because it's going down?
Oh, I used, okay, here's actually a very good thing to pay attention to, even if you're done, like, listen, so make sure you listen. Frame of reference is very important in how you orient your problem. Generally, most problems use a frame of reference based on the motion of the object, of the primary thing, right? If the general motion is one direction, usually you make that positive. Doesn't matter, you could have used negative here, right? If you use negative here, you had to make sure that you had Superman's velocity as negative. Otherwise, you would have gotten a weird answer for the time. Okay, so as long as you use, if you use down as negative, that's fine. Just make sure that your frame of reference is constant. Because if you get negative 70 here, right, and I see that you did not use a negative for the velocity, I'll probably dock you a point, just because you're trying to, use it both ways. Yeah.
So is your gravity like positive next?
I just made it positive 10, yeah. I just always make gravity 10. I never do 9.8 in here. In the regular and honors, the book always uses 9.8, so I have to do that, otherwise people freak out. But for this, just use 10. Because on the AP test, they tell you to use 10. Like in a lot of the problems. Questions? Any other questions? Yeah.
If you use negative 10,
Uh-huh.
you have to
Superman velocity?
Yeah.
Exactly.
yeah, but why?
Because if I don't use Superman velocity as negative 35, what happens to this number? Yeah, it does negative time make sense?
Oh.
Otherwise, we're traveling back in time to see what Superman passed the thing. All right, that's about it. I don't think we have any time for any more today, so